All right, we're talking about probability today. Probability basically describes the likelihood, the chance, the odds of something happening, right? Now, probability is described as a number from 0 to 1. 0, not going to happen. 1, it's for certain. Often we can describe as a fraction. We can use decimals, we can use percents. Percents are probably one of the more common ways. So for example, the probability of getting heads on a fair coin toss, we could say that's 1 out of 2. It's a 0.5 or a 50% chance, right? Now I just throw out this question, which is more likely if something has a 2% probability or a 10% probability? Well, I hope that's evident. The bigger number, right, 10% is more likely to happen than 2%. Let's go look at some examples. I've already kind of worked these out just to save time on this video, but we'll get our final answer together. So, to calculate the probability of an event, find all the ways it can happen and divide by the total number of possible outcomes. We call that a sample space. So here's a little example. Class tossed coins, they got 161 heads, 179 tails. What's the experimental probability? Now, experimental probability just means they did an experiment to determine this. Okay, of course, the theoretical probability is 50-50 that you would get heads. Round your answer to the nearest whole number. So the number of heads they got divided by the total is going to give us the probability. So I've already set this up. So 161 heads over 340. Where did that come from? Well, it's 161 plus 179. That's the total outcomes they got. And then we'll just multiply it by 100 to make it a percentage, okay? So let me just put my calculator up on the screen. Let's go ahead and calculate that quick. So if I did 161 divided by 340, so notice there's our decimal, and then if you want to just multiply by 100, or even you could just, all we're doing is moving our decimal 2 places. And so nearest whole number, I'd say, hey, that's about 47%. Okay, so about 47% heads is what they came up with. How about this little problem? A class rolled number cubes, so let's just imagine dice, you're playing a game or something. Their results are shown. What's the probability of rolling the number 2? So they got 1 42 times, 2 44 times, 3 45 times, so on and so forth. So what's the probability you get a 2? Well, that's the number of 2's divided by the total number. Is that making sense? So they got 44 2's, so I did 44, 268, I just added all these up, and then we're going to just calculate that. So very similar to what we did with the coin toss. So let's do 44 divided by 268, and again, let's just multiply it by 100, and so that's just moving your decimal 2 places. And so that would give us about 16.4%. Now I did a 0.4 there. Yeah, it said round to the nearest tenth. So depending on the question, you may just round different places. Okay? How about this one? A bag contains 36 red, 48 green, 22 yellow, 19 purple blocks. This could be blocks, marbles, rocks, whatever. You choose one block from the bag at random. What's the probability you choose a block that is not yellow? Not yellow. So it could be anything but yellow. So we basically want all the blocks that are not yellow divided by the total. So I did 103. That came from adding up the red, the green, and the purple and dividing it by the total number of blocks. So again, let's just plug that in our calculator. So 103 divided by 125. So 0.824, so if I just express that again as a percent, multiplied by 100, just slide your decimal, so that is about 82%. We could do 82.4, whatever it asks for, okay? That's rounded to the whole number there. Okay, let's look at 2 more quick. We'll wrap things up. Geometric probability. Now, you saw this stuff back in your geometry course. But it just uses lengths, areas, geometric ideas to help us find probability. Probability is still the same. It's You know, how much of this could happen divided by the total possibilities. So here's a board. Imagine we're throwing darts at it or balls or whatever. What's the probability of hitting the area inside the circle? So inside the circle. Well, that's the inside is my possible that I'm interested in. So area inside over the total area of this space. Okay? So area inside, well, how do I find area of a circle? That's pi r squared. And so I did pi times 2 squared over total area. Well, it's a rectangle, so it'll just be length times width, or width times length, however you do it. 5 times 8, so that'd be 40. So we're going to do 4 pi over 40. Of course, those will cancel, and it's just pi over 10. So we could go plug that in our calculator. So let's do pi divided by 10. And we get about 31%. Okay? So on this target, if it's just random, alright, you got about a 31% chance hitting inside. Well, what if they asked to hitting outside? Okay, it might be easiest find inside and then just subtract. If there's 31 inside, then there's 100 minus 31, or 69% of getting outside. So there's different ways you could do a problem like that. Okay, let me scoot that calculator over. Let's look at this one. What's the probability the spinner will not land in the green section? So if you spin this, you're playing a game, what's the chance you don't land in green? Well, that's all the stuff that's not green over the total. Now there's 360 degrees in a circle. So you could add up all those pink ones, or do 360 minus 75. That's 285 divided by the total, which is 360. And so we can go plug that in our calculator. So 285 divided by 360. If I can get my 0 to push there. Let me scoot this up just a little, sorry. Oh, it helps if I push the right button. So that's about 79%. So you got a 79% chance of not hitting green. Now that means you got about a 21% chance of hitting green, right? Depending on what they asked us. So that's basic probability. Hopefully that feels okay. So how could this happen? Divided by the total possible outcomes. Hey, that's how you find probability.